Most of us spend our entire lives surrounded by things we can understand. A mountain feels enormous because it stretches higher than the clouds. An ocean seems endless because we cannot see the opposite shore. Even flying across a continent can make our planet feel unimaginably large. But every one of those experiences takes place on a world that is, by cosmic standards, almost too small to notice. Imagine lifting away from Earth. Cities disappear within minutes, continents shrink into familiar shapes, and before long our entire planet becomes nothing more than a pale blue sphere floating in darkness. The moon drifts nearby, close enough that astronauts once traveled there in just a few days. Beyond it, the rest of the solar system begins to unfold. The sun dominates everything. It contains more than 99% of all the mass in our solar system, while every planet, moon, asteroid, and comet together make up less than 1%. Earth, despite being home to every human who has ever lived, is so small compared to the sun that more than 1 million Earths could fit inside it. Even that comparison fails to capture the true scale. If the sun were the size of a standard front door, Earth would be about the size of a small coin resting several meters away. Jupiter, the largest planet, would still be smaller than a basketball. The rest of the planets would become tiny ornaments, scattered across an enormous empty space. What surprises most people is that the planets themselves are not the impressive part of our solar system. It is the distance between them. Light travels faster than anything else in the universe. Every second, it circles Earth more than 7 times. It races from the moon to Earth in just over a second and reaches us, from the sun, in about 8 minutes. To us, that feels almost instantaneous. Yet even light begins to struggle when crossing our own solar system. By the time sunlight reaches Jupiter, it has already been traveling for more than 40 minutes. Neptune waits nearly 4 hours away. If we continue to the distant icy objects beyond Pluto, the journey becomes even longer. Our solar system is not a collection of nearby worlds. It is mostly empty space. And still, everything we have just described occupies only a tiny neighborhood around a single ordinary star. If we could somehow shrink our entire solar system until the orbit of Neptune fit inside a coin, the nearest star would still be several kilometers away. Between the stars lies an ocean of darkness so vast that spacecraft launched decades ago have barely begun to leave our cosmic backyard. Our Sun is only one of hundreds of billions of stars that together form a gigantic spiral known as the Milky Way. From Earth, we see it as a soft band of light stretching across the night sky. For thousands of years, people believed it was a cloud, or perhaps a river flowing through the heavens. Today we know that every faint glow in that band is produced by countless distant stars blending together until they become impossible to distinguish with the naked eye. The Milky Way is so large that light, traveling at nearly 300,000 kilometers every second without stopping for even a moment, would need around 100,000 years just to cross from one side to the other. 100,000 years. When that light began its journey, modern humans did not yet exist. Entire civilizations had not been imagined. Every language, every empire, every invention, every book, every memory of recorded history happened while that single beam of light was still making its way across our galaxy. Surely something this enormous must be close to the largest thing in the universe. After all, how could anything become much bigger than a galaxy containing hundreds of billions of stars? That assumption feels reasonable because our brains were never designed to understand scales like these. We evolved to judge the distance to a tree, a river, or a mountain. Once distances become measured in light years instead of kilometers, intuition quietly stops working. The Milky Way already seems impossible. Yet as astronomers continued exploring the universe, they discovered galaxies that made our own look surprisingly ordinary. Some contain several times as many stars. Others stretched across distances that dwarfed the Milky Way entirely. And eventually, they found something that almost defied belief. A galaxy so enormous that if the Milky Way were placed inside it, our home would seem almost insignificant. Its name is IC 1101. By the end of this journey, you may never think about the size of the universe in quite the same way again. Before we can understand how a galaxy becomes unimaginably large, we first need to answer a surprisingly simple question. What exactly is a galaxy? At first glance, the answer seems obvious. A galaxy is a collection of stars. But that description barely scratches the surface. Imagine standing on a hill overlooking a city at night. Thousands of lights stretch toward the horizon. Every window, every street lamp, every passing car belongs to something larger than itself. Roads connect neighborhoods. Gravity is replaced by infrastructure. Individual lights only make sense because they are part of a much greater system. A galaxy is similar in spirit, but on a scale so vast that every point of light is not a building, it is an entire star, many with their own families of planets. Our sun is one of those stars. Every sunrise you have ever witnessed comes from a star that is only one among hundreds of billions sharing the same galaxy. But stars are only the beginning. Between those stars float enormous clouds of hydrogen gas, stretching across hundreds of light years. These clouds slowly collapse under gravity, giving birth to entirely new generations of stars. Some regions glow with brilliant colors as newborn stars illuminate the surrounding gas, while other areas remain so cold and dark that they become nearly invisible. Dust drifts through these immense clouds as well. Although each individual particle is microscopic, together they shape the appearance of galaxies by blocking light and creating the dark lanes often seen in photographs captured by powerful telescopes. Then there are the star clusters. Some contain only a few hundred stars born together from the same cloud. Others contain hundreds of thousands packed into dense spherical swarms that have survived for billions of years, orbiting the galaxy like ancient relics from its earliest days. Everything appears wonderfully organized. Yet none of these objects explains the greatest mystery. Astronomers have measured how quickly stars orbit the centers of galaxies. According to everything we can see, the outer stars should be moving too fast. They should simply escape into intergalactic space, leaving the galaxy to slowly fall apart. But they don't. Something unseen is holding everything together. This invisible substance is known as dark matter. No telescope has ever photographed it directly. It emits no light, reflects no light, and absorbs no light. We cannot touch it or see it. Yet its gravity shapes entire galaxies, acting like an enormous invisible framework surrounding everything we can observe. In fact, the stars themselves make up only a small fraction of a galaxy's total mass. Most of what exists cannot be seen at all. Without dark matter, galaxies as we know them might never have formed. Over billions of years, gravity gathered gas into increasingly larger structures. Stars ignited. Smaller galaxies collided and merged into bigger ones. Entire systems swallowed their neighbors, growing slowly across cosmic time. Some galaxies developed elegant spiral arms, like the Milky Way, where young blue stars continue to form today. Others exhausted their gas long ago, becoming giant elliptical galaxies filled mostly with ancient stars that have been shining quietly for billions of years. No two galaxies are exactly alike. Some contain only a few million stars. Others contain hundreds of billions. A few may even contain several trillion. The differences are difficult to imagine because galaxies are not simply larger versions of one another. As they grow, their histories become more violent. Every collision leaves a permanent mark. Every merger changes their shape forever. The largest galaxies are not born large, they become large by consuming countless smaller galaxies over unimaginable spans of time. The universe, it seems, has been building them patiently for billions of years. And somewhere within that ancient history lies the story of the largest galaxy humanity has ever discovered, a galaxy so immense that even after everything we've explored so far, we are still only beginning to appreciate its true scale. By now, the Milky Way probably feels enormous. A galaxy containing hundreds of billions of stars, stretching across roughly 100,000 light-years, already seems far beyond anything the human mind can comfortably picture. If light itself requires 100,000 years to travel from one side to the other, surely we must live inside one of the giants of the universe. For a long time, astronomers wondered the same thing. The Milky Way is the only galaxy we experience from the inside. Every star we see in the night sky belongs to it. Every constellation, every nebula visible through a backyard telescope, every planet ever discovered orbiting another star, they are all members of this single vast system. Living inside it makes it feel like the entire universe. But perspective changes everything. Imagine standing inside a forest. Trees surround you in every direction. They appear endless because your view never extends beyond them. Only when you climb above the canopy do you realize the forest occupies just one valley among many. That is exactly what happened to humanity. As telescopes became more powerful, astronomers slowly climbed above our cosmic forest. One of the first surprises was that the Milky Way is not alone. It belongs to a small family called the Local Group, a collection of more than 50 known galaxies bound together by gravity. Some are graceful spirals, while others are tiny dwarf galaxies containing only a few billion stars. Compared to the Milky Way, many of these dwarf galaxies seem almost insignificant. The Small Magellanic Cloud contains only a fraction of our stars. The Large Magellanic Cloud is larger, yet still modest beside our home galaxy. Dozens of other dwarf galaxies quietly orbit the Milky Way like loyal companions, slowly losing stars as gravity pulls them apart over billions of years. Our galaxy is not simply surrounded by empty space. It is surrounded by neighbors. The largest of those neighbors is a galaxy that has fascinated astronomers for centuries. The Andromeda Galaxy. On a clear, dark night, far from city lights, you can actually see Andromeda without a telescope. It appears as a faint smudge no larger than your thumbnail held at arm's length. To the naked eye it looks almost unimpressive. Yet that tiny blur contains perhaps 1 trillion stars. Everything you see fits inside a patch of sky so small that many people mistake it for an ordinary cloud. Andromeda is slightly larger than the Milky Way. It stretches roughly 200,000 light-years across, nearly doubling the diameter of our own galaxy. It also contains significantly more stars, making it the largest galaxy in our local group. If Earth somehow existed inside Andromeda instead of the Milky Way, the night sky would appear familiar at first. Stars would still shine. Constellations would slowly drift over thousands of years. But the galaxy surrounding us would feel even grander, with a brighter central bulge and a wider disk stretching farther into space. The difference, however, would still seem subtle compared to what comes next. Andromeda and the Milky Way are already moving toward one another at over 100 kilometers every second. Despite the enormous speed, the distance separating them is so great that the collision will not occur for roughly 4 to 5 billion years. When it finally happens, it will not resemble two cars crashing into each other. Galaxies are mostly empty space. Stars are separated by such immense distances that almost none will collide directly. Instead, gravity will slowly reshape both galaxies. Their elegant spiral arms will stretch into long streams of stars before collapsing into a completely different form. Over hundreds of millions of years, two beautiful spirals will become one enormous elliptical galaxy. If any civilizations still exist by then, they may witness the most spectacular sky imaginable. Andromeda will slowly grow larger each night, eventually spanning huge portions of the heavens before dissolving into brilliant rivers of starlight as the galaxies pass through one another. Even that incredible event is only a small chapter in a much larger story. Because throughout the universe, galaxies have been colliding ever since they formed. Every giant galaxy you see today is the product of countless mergers that occurred over billions of years. Small galaxies combined to create larger ones. Those larger galaxies continued absorbing even more neighbors. Gravity patiently assembled increasingly massive systems long before Earth even existed. This means size is not an accident. It is history written across billions of years. The Milky Way itself carries scars from ancient collisions. Astronomers have discovered streams of stars wrapping around our galaxy like invisible rivers, remnants of dwarf galaxies that wandered too close and were torn apart by gravity. Even today, the Milky Way continues growing, quietly consuming smaller companions one after another. Our galaxy is still under construction. Yet despite all of these mergers, despite hundreds of billions of stars and a history stretching back nearly the age of the universe, the Milky Way is considered only a large spiral galaxy. Not extraordinary. Not record-breaking. Simply large. Once that realization sinks in, a new question naturally follows. If galaxies can keep growing through mergers, just how large can they become? The answer lies far beyond our local group, in regions of space where gravity has been assembling monsters for billions of years. Leaving the local group feels almost like leaving a small town. The familiar galaxies disappear behind us. Distances become measured not in millions of light years, but in hundreds of millions. Space begins filling with galaxy clusters, vast cities of galaxies containing hundreds or even thousands of members, all bound together by gravity. These are some of the largest structures held together in the universe. Inside a galaxy cluster, the sky would look completely different from anything we know. Instead of seeing only the faint glow of the Milky Way stretching overhead, enormous neighboring galaxies would dominate the heavens. Some would appear many times larger than our full moon, glowing softly across the night. Others would drift nearby as brilliant islands of light, each containing hundreds of billions of stars. The universe would suddenly feel crowded. Clusters are not peaceful places. Galaxies race through them at speeds of thousands of kilometers every second. Invisible clouds of extremely hot gas fill the space between galaxies, reaching temperatures of tens of millions of degrees. Although the gas is incredibly thin, it contains more ordinary matter than all the stars within the galaxies themselves. Everything is in motion. Everything is interacting. And gravity never rests. Near the centers of these clusters, something remarkable often happens. The largest galaxy begins attracting smaller neighbors. One after another, galaxies fall inward, their stars slowly stripped away by gravity. Entire spiral galaxies are stretched apart, their elegant arms erased forever as they become part of something much larger. Astronomers sometimes describe this process as galactic cannibalism. It sounds dramatic, yet it is simply gravity doing what gravity has always done. A smaller galaxy approaches the cluster's center. Its orbit decays. Over millions of years, stars are pulled loose, dark matter merges with the larger halo, and eventually almost nothing remains of the original system except faint streams of stars wrapping around the growing giant. Then another galaxy arrives. And another. This process repeats over billions of years. The largest galaxies never stop eating. Unlike spiral galaxies such as the Milky Way, these giants often lose their graceful structure entirely. Their rotating disks disappear. Their spiral arms vanish. What remains is a massive elliptical galaxy, smooth, rounded, and filled mostly with old stars that have long since stopped forming new generations. At first glance they almost appear simple. Yet simplicity can be deceiving. These galaxies are among the most massive objects ever assembled by gravity. Some contain several times more stars than the Milky Way. Others possess dark matter halos extending millions of light-years into space. At their centers sit supermassive black holes weighing billions of times more than our Sun, quietly influencing everything around them. One famous example is Messier 87. Located roughly 55 million light-years away, it dominates the center of the Virgo cluster. This giant elliptical galaxy contains trillions of stars and houses one of the largest known black holes in the nearby universe. In 2019, it became the first black hole ever directly imaged, revealing the glowing ring of material falling toward the darkness at its center. For many years, galaxies like Messier 87 seemed almost impossibly large. Then astronomers discovered others. NGC 4889, near the center of the Coma cluster, contains an equally astonishing black hole and an immense population of ancient stars. Across the observable universe, more colossal ellipticals continued appearing, each one larger than the last. Every new discovery pushed the limits of what scientists believed possible. Yet these galaxies were still not the largest. There was another giant waiting farther away. A galaxy so immense that even among the titans of galaxy clusters, it stood apart. Its light began traveling toward Earth more than 1 billion years ago, long before multicellular life had fully transformed our own planet. By the time that ancient light finally reached our telescopes, humanity had only recently learned how to build machines capable of detecting it. At first it appeared to be just another bright elliptical galaxy near the center of a distant cluster. But as astronomers carefully measured its size, they realized they were looking at something extraordinary. This galaxy was unlike anything they had ever seen before. It stretched across a distance so enormous that even the Milky Way, Andromeda, Messier 87, and nearly every other familiar galaxy would seem modest by comparison. Its name was IC 1101. And even today, decades after its discovery, simply describing its size requires comparisons so extreme that our intuition begins to fail. In the next chapter, we will leave behind every familiar scale we have used so far and step inside the largest galaxy humanity has ever discovered, a place where even light spends millions of years crossing from one side to the other, and where the meaning of big changes forever. There comes a point where numbers stop meaning anything. 10,000 is easy to imagine. A million is more difficult. A billion already stretches the limits of intuition. By the time we reach trillions, our minds quietly give up, treating every unimaginably large number as simply very big. That is why galaxies like IC 1101 are so difficult to understand. Not because the science is complicated, but because evolution never prepared our brains for scales like this. IC 1101 lies about 1 billion light-years from Earth in the constellation of Serpens. The light entering our telescopes tonight began its journey long before dinosaurs disappeared from our planet. While that ancient light crossed the expanding universe, continents shifted, species evolved, civilizations rose and fell, and every chapter of human history unfolded in its entirety. Only now are we finally seeing it. At first glance, IC 1101 appears surprisingly ordinary. Unlike the magnificent spiral arms of the Milky Way or the elegant shape of Andromeda, IC 1101 is an enormous elliptical galaxy. It resembles a soft oval glow fading gently into darkness. There are no dramatic arms winding around its center. No obvious patterns. No colorful lanes of gas and dust. It almost looks quiet. Yet appearances can be misleading. Beneath that calm exterior lies one of the largest collections of stars ever discovered. The Milky Way stretches roughly 100,000 light-years across. IC 1101 is estimated to span close to 6 million light-years from one side to the other. Pause for a moment and let that comparison settle in. If our galaxy were reduced to the width of a single sheet of paper, IC 1101 would stretch across an entire room. If the Milky Way were the size of a football stadium, IC 1101 would be larger than many cities. The difference is not 2 times bigger, or 10 times bigger. It is on a completely different level. Imagine placing the Milky Way inside IC 1101. Our galaxy would occupy only a tiny portion of the giant's immense diameter. Hundreds of Milky Ways could fit across its widest extent, one after another, before reaching the opposite edge. Now remember what that actually means. Each one of those Milky Ways contains hundreds of billions of stars. Each of those stars may possess planets. Some of those planets could resemble Earth. Every civilization humanity has ever imagined could exist within just one tiny fraction of this immense galaxy. The scale becomes almost impossible to hold in your thoughts. Astronomers estimate that IC 1101 may contain several trillion stars. The exact number remains uncertain because galaxies this large blur gradually into the surrounding sea of stars within their cluster. There is no sharp edge where the galaxy suddenly ends. Instead, its outer regions slowly fade into intergalactic space, making it surprisingly difficult to define its true size. In a sense, IC 1101 is so large that even measuring it becomes challenging. Its enormous halo of stars extends far beyond the bright central region visible in most photographs. Countless ancient stars drift through space, loosely bound by gravity, tracing the long history of mergers that built the galaxy over billions of years. Every one of those stars has its own story. Many were not born inside IC 1101 at all. They belonged to entirely different galaxies. Long ago, smaller galaxies wandered too close. Gravity slowly pulled them apart, stripping away their stars until nothing recognizable remained. Over billions of years, those stolen stars became permanent citizens of the growing giant. IC 1101 is less like a single galaxy and more like a museum of countless galaxies that no longer exist. Every merger left behind another layer. Every collision increased its size. Every billion years, it grew a little larger. The galaxy we observe today is the final result of an unimaginably long process of cosmic construction. And astonishingly, that process required no architects. No design? No intention. Only gravity. One simple force, acting patiently for nearly the entire age of the universe, created something so enormous that human language struggles to describe it. Yet even after hearing these numbers, it is still difficult to feel their meaning. Perhaps there is a better way. Instead of measuring IC 1101 with telescopes, imagine standing inside it. Imagine looking up from one of its countless stars and asking a simple question. What would life actually be like in the largest galaxy humanity has ever discovered? Imagine waking up on a planet orbiting an ordinary star somewhere inside IC 1101. Your sun rises. Your world feels familiar. Mountains stand silently beneath the sky. Oceans reflect the light of a nearby star. Gravity feels the same. Seasons come and go. If intelligent life existed there, its inhabitants might spend centuries believing they lived in a perfectly ordinary corner of the universe. In many ways, they would. Because no matter how enormous a galaxy becomes, life experiences only a tiny piece of it. Even here on Earth, we have never traveled beyond our own solar system. Every spacecraft humanity has ever launched remains astonishingly close to the Sun compared with the size of the Milky Way. The same limitation would exist inside IC 1101, only on a scale almost beyond imagination. Suppose a civilization developed technology capable of traveling at the speed of light. According to everything we understand about physics, that is impossible for anything with mass, but let us imagine it for a moment. In our Milky Way, crossing from one side of the galaxy to the other would require around 100,000 years. Inside IC 1101, the same journey could take millions of years. Not hundreds. Not thousands. Millions? An expedition leaving one edge of the galaxy before the first humans appeared on Earth would still not have reached the opposite side today. Entire species could evolve, go extinct, be forgotten. And the journey would still continue. Communication becomes equally astonishing. Imagine sending a message to another civilization located on the opposite side of IC 1101. Even if your signal traveled at the speed of light, countless generations would live and die before anyone received it. By the time a reply arrived, the civilization that sent the original message might no longer exist. Within galaxies like this, distance becomes its own kind of isolation. It raises a fascinating possibility. Perhaps intelligent civilizations have existed within the same galaxy without ever knowing about one another. Not because they lacked technology. Not because they were hiding. Simply because the universe is too large. We often imagine galaxies as bustling collections of neighboring stars. In reality, they are immense deserts of darkness. Even near the center of IC 1101, stars remain separated by incredible distances. Space is still mostly empty. The night sky might contain more distant stars than ours, but reaching even the nearest one would remain an extraordinary challenge. Size alone does not bring closeness. It only creates more space. Now imagine looking upward during the night. What would the sky actually look like? Near the galaxy's crowded central regions, billions of additional stars would brighten the heavens. The distant glow of the galaxy itself might appear far more brilliant than the Milky Way appears from Earth. Dense rivers of ancient stars would stretch overhead, filling much of the sky with soft golden light. Yet despite those countless suns, darkness would still dominate. That may seem surprising. Shouldn't a galaxy containing trillions of stars shine almost like daylight? The answer is no. Because even in the largest galaxies, stars remain separated by distances so enormous that most of their light never reaches neighboring systems. Space expands between them like an endless ocean. The universe is remarkably efficient at creating emptiness. In fact, if you removed every star from IC 1101 and compressed all of their matter together, the empty space between them would still account for almost everything the galaxy occupies. The true substance of a galaxy is not stars. It is space. That idea changes the way we think about the cosmos. We often picture galaxies as crowded islands of light, but they are closer to invisible frameworks holding tiny points of brightness impossibly far apart. Most of the volume inside even the largest galaxy contains almost nothing at all. And hidden beneath all of that emptiness lies something even stranger. Everything we have described so far, the trillions of stars, the glowing gas, the ancient clusters, the faint halos, represents only the visible portion of IC 1101. Surrounding the entire galaxy is an even larger structure that cannot be seen by any telescope. An enormous halo of dark matter. Invisible. Silent. Yet vastly more massive than all the stars combined. Without it, IC 1101 could never have become the giant it is today. To understand the true size of this galaxy, we must look beyond the light itself and explore the invisible foundation holding everything together. When we first hear about IC 1101, it is tempting to imagine that it was born enormous. Perhaps a gigantic cloud of gas collapsed shortly after the Big Bang, creating an impossibly large galaxy from the very beginning. But that is not how the universe builds its giants. Nature almost never creates something this large in a single step. Instead, it begins with something much smaller. To understand IC 1101, we must travel backward through time, nearly 14 billion years, to an era when galaxies barely existed at all. Shortly after the Big Bang, the universe was a remarkably simple place. There were no planets, no stars, no galaxies, and certainly nothing resembling the colossal structures we observe today. Space contained mostly hydrogen and helium drifting through darkness, along with tiny fluctuations in density that appeared almost insignificant. Those tiny differences changed everything. Some regions contained just a little more matter than others. Gravity strengthened those regions ever so slightly, attracting additional material. As more matter accumulated, gravity became stronger still, pulling in even more gas and dark matter. It was an incredibly slow process. Millions of years passed. Then hundreds of millions. Eventually, the first stars ignited. Those early galaxies looked nothing like the graceful spirals filling astronomy books today. They were smaller, irregular, chaotic systems filled with intense bursts of star formation. They collided constantly because the young universe was much smaller than it is now, leaving galaxies packed closer together than they are today. Every collision became an opportunity for growth. Two galaxies approached one another. Gravity distorted their shapes long before they actually met. Their stars continued moving almost untouched because the distances between individual stars were so enormous, but the galaxies themselves began exchanging gas, dark matter, and entire star clusters. Slowly, they merged. The result was a larger galaxy. Then that larger galaxy merged with another. And another. This process repeated over billions of years like an endless cosmic construction project. Unlike buildings on Earth, galaxies have no final blueprint. They simply keep growing whenever gravity delivers another neighbor. Astronomers often refer to this process as hierarchical formation. Large galaxies are assembled piece by piece from countless smaller ones, each merger adding another chapter to their history. If we could somehow rewind IC 1101 like a movie played backward, we would not see one giant galaxy shrinking into nothing. Instead, we would watch it break apart into hundreds, perhaps thousands, of smaller galaxies drifting away from one another. Every one of those galaxies would continue dividing into even smaller systems until the early universe became filled with tiny building blocks waiting for gravity to assemble them once again. The largest galaxies are not ancient because they were born large. They are ancient because they have been growing for almost the entire lifetime of the universe. But growth alone does not explain why IC 1101 became so much larger than almost everything else. Location matters. IC 1101 sits near the center of a massive galaxy cluster known as Abell 2029. Imagine placing a city at the bottom of an enormous valley. Rainwater naturally flows downhill toward the lowest point. In a similar way, gravity draws galaxies toward the deepest part of a cluster. Over billions of years, countless galaxies slowly spiraled inward. Some passed safely by. Others were not so fortunate. The closer they came to the cluster's center, the stronger the gravitational forces became. Smaller galaxies lost stars first. Their delicate spiral arms stretched into enormous streams. Eventually their central regions collapsed into the growing giant waiting at the heart of the cluster. IC 1101 did not chase other galaxies. They came to it, one after another. Patiently. Relentlessly. Astronomers sometimes call this galactic cannibalism, and although the name sounds dramatic, it is remarkably accurate. The giant galaxy consumes smaller neighbors, incorporating their stars, their gas, their dark matter, and even their central black holes into itself. The evidence remains visible today. Around many giant elliptical galaxies, astronomers observe faint streams of stars extending far into space. These stellar rivers are the final remains of galaxies that once existed independently before being torn apart by gravity. IC 1101 is likely surrounded by countless such streams, many now blended together so completely that separating them has become nearly impossible. Its enormous size is not the story of one galaxy. It is the story of many galaxies that disappeared. Every star drifting through its outer halo may once have belonged to another home. Every orbit tells part of a history stretching back billions of years. Every faint glow reminds us that the universe is constantly changing, even if those changes unfold so slowly that no human lifetime could ever witness them. Yet there is another mystery waiting at the very center of this giant. A mystery hidden behind gravity so intense that even light itself cannot escape. Because every galaxy, no matter how large or small, appears to share one remarkable feature. At its heart lies a black hole. And inside a galaxy as enormous as IC 1101, that black hole must be extraordinary. When most people imagine a black hole, they picture something enormous, swallowing everything nearby like a giant vacuum cleaner drifting through space. The reality is both stranger and more fascinating. Black holes are not cosmic monsters wandering randomly across the universe. They are anchors. Nearly every large galaxy we have ever studied appears to contain one at its center. Even our own Milky Way has one. Known as Sagittarius A, the black hole at the center of our galaxy contains about 4 million times the mass of our Sun. That number sounds impossibly large until we compare it with black holes found inside giant elliptical galaxies. Then our own suddenly seems modest. Some supermassive black holes contain billions of solar masses. Not millions. Billions? They outweigh entire dwarf galaxies. And they sit quietly at the centers of the largest galaxies ever discovered. Astronomers have not yet measured the exact mass of the black hole inside IC 1101 with complete certainty, but every piece of evidence suggests it is among the most massive black holes in the universe. It may contain tens of billions of times the mass of our Sun, making it one of the greatest concentrations of matter known to exist. Trying to imagine such an object is almost impossible. If our Sun were replaced by a black hole of the same mass, Earth's orbit would not change at all. We would continue circling exactly as before because gravity depends on mass, not on whether that mass forms a star or a black hole. The difference is that sunlight would disappear forever. Now imagine replacing the Sun with something containing tens of billions of solar masses. Not because it belongs inside our solar system, it certainly does not, but simply to appreciate the scale. Its gravitational influence would dominate everything around it. Stars thousands of light-years away would orbit its immense gravity. Entire star clusters would dance around an object that emits no light of its own. Surprisingly, even a black hole this massive does not control the entire galaxy. That idea often surprises people. The stars in the outer regions of IC 1101 are simply too far away. Their motion is influenced much more by the combined gravity of trillions of stars and an enormous halo of dark matter than by the central black hole itself. The black hole rules the heart of the galaxy. Gravity rules everything else. So how did such a monster become so massive? The answer mirrors the history of the galaxy surrounding it. Every time IC 1101 absorbed another galaxy, it likely absorbed another central black hole as well. At first, the two black holes orbited each other from enormous distances, slowly losing energy over millions of years. Eventually they spiraled together and merged into a single, even larger black hole. This process repeated again and again. Over billions of years, the black hole grew alongside its galaxy. Stars merged. Galaxies merged. Black holes merged. Everything became larger together. Occasionally, enormous amounts of gas fall toward the central black hole instead of immediately disappearing inside it. As the gas spirals inward, it forms a blazing disk reaching temperatures of millions of degrees. Friction causes the material to glow more brightly than entire galaxies, releasing astonishing amounts of energy before finally crossing the event horizon. For brief periods in cosmic history, the centers of giant galaxies become some of the brightest objects in the observable universe. These are known as active galactic nuclei, or quasars when they are especially luminous. Ironically, the brightest objects in the universe are powered by places from which no light can escape. That apparent contradiction is one of the universe's most beautiful tricks. The light comes not from inside the black hole, but from material desperately trying to avoid falling in. Today, IC 1101 appears relatively calm. Much of the gas that once fed its central black hole has already been consumed or blown away over billions of years. The brilliant fireworks of its youth have faded, leaving behind an ancient galaxy filled mostly with old stars quietly orbiting through space. It has entered a quieter stage of life. Yet beneath that peaceful appearance, the black hole remains. Invisible. Silent. Patient. Waiting for anything that wanders too close. And despite everything we have explored, the trillions of stars, the millions of light years, the giant black hole, we have still not reached the largest structures in the universe. Because galaxies themselves are only pieces of something even greater. IC 1101 may seem like the ultimate giant, but when viewed from far enough away, even this colossal galaxy becomes just another point of light woven into an unimaginably vast cosmic web. After everything we have explored, it is tempting to believe that IC 1101 must be close to the largest object in existence. A galaxy millions of light years across, containing trillions of stars and an unimaginably massive black hole, already feels like the upper limit of what nature could possibly create. But the universe has one final habit. Just when we think we have reached the largest scale, it quietly reveals another. To understand this, imagine looking down at Earth from space. Cities seem enormous when you walk through them. Skyscrapers dominate the skyline. Highways stretch to the horizon. Yet from orbit, entire cities become tiny patterns etched onto the landscape. The same thing happens to galaxies. As we continue pulling away from IC 1101, the galaxy that once filled our imagination slowly shrinks. Its brilliant central glow becomes a single point of light, almost indistinguishable from thousands of others scattered throughout the darkness. The scale has changed again. IC 1101 does not drift through space alone. It sits near the center of Abell 2029, one of the richest galaxy clusters in the nearby universe. This immense cluster contains thousands of galaxies, each following its own path, through an invisible ocean of gravity. Some are spirals, still forming stars. Others are giant ellipticals that have long since exhausted their supplies of gas. Tiny dwarf galaxies move quietly between them, often destined to become part of larger systems in the distant future. If the Milky Way were the size of a grain of sand, a galaxy cluster would resemble an entire beach. Distances that once seemed extraordinary suddenly become ordinary. Between the galaxies lies something almost as remarkable as the galaxies themselves. An enormous cloud of superheated gas fills much of the cluster. Although this gas is incredibly thin, far thinner than the best vacuum humanity can create on Earth, it stretches across millions of light years. Altogether, it contains more ordinary matter than all of the stars inside the cluster combined. Invisible to our eyes, it glows brightly in X-rays, revealing the hidden structure of the cluster to space telescopes. But even galaxy clusters are not isolated. Gravity gathers them into even larger families known as superclusters. For many years, astronomers believed these superclusters represented the largest structures in existence. They seemed impossibly vast, containing tens of thousands of galaxies, spread across hundreds of millions of light years. Then the map of the universe became clearer. Instead of isolated islands, astronomers discovered something breathtaking. Galaxies, clusters, and superclusters are connected by enormous filaments, stretching across the observable universe like the threads of an unimaginably large web. This structure is known simply as the cosmic web. If we could somehow illuminate every galaxy in the universe and watch them from an impossible distance, we would not see random dots scattered through space. We would see a network. Long glowing filaments connect enormous knots where galaxy clusters gather. Between those filaments lie immense cosmic voids, regions so empty that millions of light years may pass without encountering another major galaxy. The universe resembles neither a solid object nor a uniform cloud. It resembles a living web. The comparison is almost unsettling. Viewed from certain angles, the cosmic web bears a remarkable resemblance to networks found elsewhere in nature. Some scientists have noted similarities to neural pathways inside the human brain, while others compare it to microscopic patterns created by growing organisms. These similarities arise not because the universe is literally alive, but because simple physical laws often produce beautiful, repeating structures across vastly different scales. Nature enjoys patterns. Gravity is one of its greatest artists. Within this cosmic web, even IC 1101 loses its special status. The largest galaxy humanity has ever discovered becomes just one bright point among countless others. The object that once seemed almost beyond comprehension now appears no more significant than a single streetlight viewed from an airplane. Perspective changes everything. It reminds us that words like large and small depend entirely on where we choose to stand. A mountain towers over a person. Earth dwarfs every mountain. The sun dwarfs Earth. The Milky Way dwarfs the sun. IC 1101 dwarfs the Milky Way. Galaxy clusters dwarf IC 1101. The cosmic web dwarfs them all. And yet, everything we have described still belongs to only one portion of the observable universe. Beyond the edge of what we can see lies more space. More galaxies. More clusters. More cosmic web. not because we know what is there, but because the universe continues beyond the distance light has had time to travel since the Big Bang. The observable universe is not the entire universe. It is only the part whose light has reached us. That realization is both exciting and humbling. Somewhere beyond our cosmic horizon may exist galaxies larger than IC 1101. Entire clusters we will never observe. Structures whose light will never reach Earth, no matter how long humanity survives. The universe may contain wonders forever hidden from us. And that leads to one final question. If IC 1101 is only the largest galaxy we have found so far, could something even larger already exist? Science has a remarkable history of replacing certainty with curiosity. Again and again, humanity has declared that it had found the largest mountain, the deepest ocean, the oldest fossil, or the most distant object in the universe. Then someone looked a little farther. Every discovery reminds us that our knowledge is limited not only by intelligence, but by what our instruments allow us to see. IC 1101 currently holds its place among the largest known galaxies, but astronomers are careful with their wording. Known? That single word changes everything. The universe is unimaginably large. The observable universe alone contains hundreds of billions, and perhaps even trillions of galaxies. Every year, new telescopes reveal objects that previous generations never imagined. What seems extraordinary today may one day become surprisingly common. For decades, many giant galaxies remained invisible simply because they were too far away or too faint for earlier telescopes to study properly. Then technology improved. Space telescopes began observing wavelengths that Earth's atmosphere blocks completely. Massive digital detectors collected more light than photographic plates ever could. Computers processed faint signals hidden beneath cosmic noise, revealing galaxies that had quietly existed all along. The universe had not changed. Only our ability to see it had. One of the greatest advances came with the launch of the James Webb Space Telescope. Designed to observe infrared light, it allows astronomers to peer farther into cosmic history than ever before. Webb has already discovered surprisingly massive galaxies that formed much earlier than many models predicted. Some appeared so quickly after the Big Bang that astronomers are still working to understand how they grew so large in such a short time. Every new discovery forces scientists to ask new questions. Did galaxies form faster than expected? Were conditions in the early universe different from our current models? Or are we still missing important pieces of the story? These mysteries make astronomy one of the most exciting sciences today. Every answer creates another question. Could Webb eventually discover a galaxy even larger than IC 1101? It is certainly possible. Perhaps, somewhere beyond our current surveys lies another giant, whose faint outer halo has escaped detection. Perhaps, several neighboring galaxies have not yet fully merged, causing astronomers to classify them separately even though they will eventually become one enormous system. The universe has surprised us many times before. There is another possibility as well. What if IC 1101 is already close to the practical limit? Growing a galaxy requires raw material. Smaller galaxies must continue falling inward, bringing additional stars and dark matter with them. But the universe itself is expanding. On the largest scales, galaxies are slowly moving farther apart, carried away by the expansion of space. Over immense stretches of time, that expansion reduces opportunities for future mergers. The largest galaxies may eventually stop growing, not because gravity becomes weaker, but because distant galaxies drift beyond reach. In a sense, the universe has a closing window. For billions of years, gravity built ever larger structures. One day, expansion may quietly bring that era to an end. Future civilizations living trillions of years from now could look into the sky and see a far lonelier universe than we do today. Most distant galaxies will have moved so far away that their light can no longer reach them. They may conclude that their galaxy is the entire universe, never realizing that countless others once filled the cosmos. Ironically, we may be living during one of the best possible moments in cosmic history to study the universe. The evidence is still visible. The galaxies are still close enough to observe. The ancient light is still arriving. We are witnessing a brief chapter that future astronomers may never experience. And yet, perhaps the most astonishing thought is not whether a galaxy larger than IC 1101 exists. It is that somewhere, on one of the trillions upon trillions of planets, scattered across these unimaginable galaxies, another civilization might be asking the very same question. Looking toward the darkness. Searching for distant galaxies. Wondering how large the universe can truly become. Never knowing that, separated by millions or even billions of light years, someone else is wondering exactly the same thing. In our next and final chapters, we will leave behind measurements and discoveries and ask a more profound question. Why does the universe contain structures so vastly beyond human comprehension? And what does that tell us about our place within it? For billions of years, IC 1101 has been growing. Every collision with another galaxy made it larger. Every merger added billions of new stars, more dark matter, and often another supermassive black hole to its history. Gravity has spent nearly the entire lifetime of the universe building this giant, but even gravity cannot keep building forever. Every galaxy, no matter how large, eventually reaches a point where growth slows, and then begins to change in a completely different way. Unlike spiral galaxies such as the Milky Way, IC 1101 has very little raw material left to create new stars. Long ago, much of its hydrogen gas was either converted into stars or heated to temperatures so high that it can no longer collapse under gravity. This is one of the defining characteristics of giant elliptical galaxies. They are often described as red and dead, not because they have disappeared, but because most of their stars are old, cool, and nearing the final stages of their lives. The brilliant blue stars that once illuminated the galaxy burned through their fuel billions of years ago. What remains today is a vast population of ancient stars that continue orbiting quietly through space. If we could accelerate time and watch IC 1101 over the next 100 billion years, the changes would be almost invisible at first. One by one, the most massive stars would disappear, ending their lives in spectacular supernova explosions before leaving behind neutron stars or black holes. Smaller stars would continue shining for much longer, while stars like our own Sun would slowly expand into red giants before ending as white dwarfs. Throughout the galaxy, countless planetary systems would experience their own endings as the stars that gave them warmth gradually faded away. Over even longer periods of time, trillions of years into the future, only the smallest red dwarf stars would remain. These stars burn their hydrogen so efficiently that some are expected to survive for trillions of years, making them the last true sources of starlight in the universe. During this era, IC 1101 would look dramatically different from the galaxy we observe today. Instead of trillions of bright stars filling the darkness, only scattered red dwarfs would continue shining, surrounded by enormous populations of cold stellar remnants drifting silently through space. Eventually, even those last stars will exhaust their fuel. At that point, the galaxy will no longer resemble the magnificent island of light we see today. It will become a collection of white dwarfs, neutron stars, black holes, cold planets, and countless objects too dark to be seen. The immense structure of the galaxy will still exist because gravity continues acting even after the stars have stopped shining, but visually it would appear almost invisible against the darkness of space. The central black hole, however, will continue dominating the heart of the galaxy. Over unimaginably long periods of time, wandering stars and smaller black holes may slowly fall toward the center, occasionally merging with the supermassive black hole and increasing its mass even further. Every merger would send powerful gravitational waves across the universe, ripples in spacetime traveling outward at the speed of light. These events would become increasingly rare as the galaxy aged, but gravity would never truly stop working. According to our current understanding of physics, even black holes are not eternal. In the 1970s, physicist Stephen Hawking proposed that black holes slowly lose energy through a process now known as Hawking radiation. For small black holes, this process is relatively quick by cosmic standards. For a supermassive black hole like the one expected at the center of IC 1101, the timescale is almost impossible to comprehend. It would survive for numbers of years so large that writing them down requires more digits than there are seconds in the entire history of the universe. Only after an almost unimaginable length of time would even this giant finally evaporate into the surrounding darkness. By then, the universe itself will have changed beyond recognition. Most galaxies will have exhausted their stars. The brilliant night skies that once filled countless planets with light will be gone, replaced by an increasingly cold and quiet cosmos. IC 1101, once one of the largest and brightest galaxies in existence, will have completed its extraordinary journey from a growing giant to a silent collection of dark remnants. It is a reminder that nothing in the universe remains unchanged forever. Stars evolve, galaxies evolve, and even the greatest structures ever assembled by gravity eventually become part of an even larger story. Throughout this journey, we have traveled farther than the human mind naturally evolved to think. We began on Earth, surrounded by mountains, oceans, and continents that once seemed enormous. We left our planet and discovered that it is only a tiny world orbiting an ordinary star. We crossed the Milky Way and realized that our home galaxy is only one among hundreds of billions in the observable universe. Then we reached IC 1101, a galaxy so immense that our own appears almost insignificant beside it. And finally, we stepped back even farther to see galaxy clusters, the cosmic web, and the largest structures known to exist. Yet perhaps the most remarkable discovery is not the size of IC 1101 itself. It is the realization that our intuition completely fails long before we ever reach scales like this. Human beings did not evolve to understand millions of light years or trillions of stars. Our ancestors learned to judge the distance to a nearby river, estimate the height of a tree, or recognize the shape of a mountain. Those instincts were perfect for surviving on Earth, but they become almost meaningless when applied to the universe. That is why astronomers constantly rely on comparisons. They shrink the Earth to the size of a marble, the Sun to a basketball, or the Milky Way to a city. These analogies are not simply teaching tools. They are the only practical way to bridge the enormous gap between everyday experience and cosmic reality. Without them, numbers such as 6 million light-years or several trillion stars become little more than abstract symbols with no emotional meaning. Even those comparisons eventually reach their limit. There is no everyday experience that prepares someone to imagine a beam of light traveling for millions of years across a single galaxy. There is no object on Earth large enough to represent trillions of stars without losing the comparison entirely. At some point, the universe simply becomes larger than language itself. Perhaps this is why astronomy has fascinated humanity for thousands of years. Every generation has believed it was beginning to understand the universe, only for the next generation to discover that reality was even larger. We once believed our solar system was the universe. Later we discovered the Milky Way. Then we realized the Milky Way was only one galaxy among billions. Today we continue finding galaxies that challenge our understanding of how quickly structures formed after the Big Bang, reminding us that the universe still holds many surprises. IC 1101 is currently one of the largest galaxies ever discovered, but history suggests we should be cautious whenever we use words like largest. Every improvement in technology allows astronomers to see a little farther into space and a little farther back in time. New telescopes reveal galaxies that previous generations could never detect. Future observatories may discover systems even larger than IC 1101 or reveal entirely new types of structures that we have not yet imagined. Science does not promise that today's answers are final. Instead, it gives us increasingly accurate descriptions of a universe that continues to surprise us. When you look up at the night sky after watching this documentary, nothing will appear different. The same stars will shine overhead. The Milky Way will still stretch faintly across dark skies far from city lights. But perhaps your perspective will have changed. Every star you see belongs to one ordinary galaxy. That galaxy belongs to a universe filled with hundreds of billions of others. Somewhere nearly 1 billion light-years away, ancient light continues leaving the countless stars of IC 1101 exactly as it has for millions of years. Some of that light is reaching Earth tonight, carrying with it a glimpse of one of the greatest structures gravity has ever assembled. The universe has a remarkable way of humbling us. Every time we believe we have reached the largest scale imaginable, it quietly reveals something even greater. Mountains give way to planets. Planets give way to stars. Stars give way to galaxies. Galaxies give way to clusters, and clusters become threads in a cosmic web stretching across the observable universe. Perhaps that is the greatest lesson hidden within the story of IC 1101. The universe is not simply bigger than we once believed. It is larger than our imagination itself, and every new discovery reminds us that there are still wonders waiting beyond the edge of everything we currently know.